so this is what we are working on, right? So as I said, we had created the employee class. That was an abstract class. Abstract classes cannot be instantiated. That is, you cannot create instances or objects of such a class, but they can definitely be extended. So they have their use. Common instance variables and common methods that are being inherited throughout the hierarchy can go here in the employee class. And then any method that will be different in all other classes, I can give it a definition. I make it abstract in my employee class. So that's its use, okay? So an abstract class is a class that cannot be instantiated, but can be extended. And common methods, whatever you need, anything that's common to its subclasses can go in here. And anything that is common, you want every employee to have a salary, of course, but you do not know how it will be calculated. So you create an abstract method in the employee class, which has to be overridden by every class that extends it as long as it is concrete. If it is not concrete, then it can leave it alone. Then it doesn't have to override it. But in my picture right here, all my employee classes, the base, the hourly, the commission employee, all of these are concrete classes. So they definitely have to override the get earnings method. So we had left off here. So my employee class was ready. So this was your employee class. It was an abstract class. It's recognized by the abstract word in your class signatures. And we had talked about final variables and so on. At this point of time, hopefully this is all clear. We had also said that the first call should be super in the constructor. We had also talked that we should not be calling overridable methods in the constructor. So I've started using my this, and anytime I need a validation, I kind of put it in a common private method and then use it in my set in my constructor. This class has one abstract method. And there it is. That's the abstract method. An abstract method does not have an implementation. Does not even opening, closing brackets. There's nothing associated with it. The commission employee was extending the employee. By default, every class extends object if I don't have the object. So now commission employee is extending two classes in a way. You can't write more than one extends. In Java, you can only extend from a class, but there is a way of using more than one classes, which we will learn in implements interfaces. So what it has done is it has extends employee, and employee has extended object. So now this class can use all methods and instance variables of object and all methods and instance variables of employee as long as they are not private, right? Private methods are not, or objects or instance variables are not inherited. I mean, those are private to the class. Static is okay. Statics are fine because you can use it with the class name, right? And then what this class does it, so we are moving from generic to specific. Keep in mind, though the hierarchical diagram looks like this, it seems as if they are bigger. The classes are bigger, the code is more, but they become more specific. So now the commission employee has two more instance variables, name and social security number was fine, but now it has two more, a gross sales and a commission rate, because the earnings of a commission employee are based on what his sales are, okay? And so we have these two instance variables, the constructor as we write, called the super. And notice how I'm calling not set methods, which are public. Now I'm calling validate gross sales, which is a private method of my class in which I do my validation. And I call this also from my set method. So do not call overridable methods from the constructor. And overridable means it can be overridden in its subclasses, which means it's public. So don't call public methods. So what I did was, and this is how you should work now onwards in your third course also when you go, hopefully it will stay, that you call a private method in which you validate whatever you have to validate. And since validation is important, I keep it at one place instead of copying it at two places in my constructor and in my set. I just keep it at one place and I call this validate both from the constructor and from my set methods. Go ahead, Henry.
For example, in this class, we have this validate gross sales.
Yeah.
Method. It's called from the constructor.
Yep.
So do we really need a set gross sales?
Okay, now why do we need a set gross sales? Remember, set method is used if you would like to change anything from outside, right? So in my employee, I made my social security number final. Once assigned, you cannot do anything. So I don't have a set method. But here, if I wanted to change the gross sales of a commission employee, how will I do it? I have to have a set method. right? So we need the set method. So you decide whether you need a set method or not. So logically, we've been arguing like this. The sales of a commission employee will change, will definitely change, right? Maybe he sold 1,000 worth this month, 2,000 next month, and so on. So it will change. You don't want to, there is another way of doing it, Henry. You could kill the whole object. You could dispose it off and create a new one. That's not what you do. You don't want to do that. Once, for example, once you join Georgian College and in the first semester, all your record is there, then they don't kill your records and create a new one. All that changes is, oh, this person has now gone from semester 1 to semester 2, for example. Right? So they change your semester number. So they do need a set. So set methods are needed. They are needed if you think that that instance variable will need a change. If not, then you don't need it. Right? So definitely in final variables, because once assigned, we don't need to change them. We don't have it. Right? So keep that in mind. Like, for example, you can understand it so easily. Your student ID will be final. Once it is assigned to you, it never changes. Your name could change, so we'll leave that non-final, and then your semester number, even your program, anything can change, right? People change programs. People definitely change semesters as they move on. So all these instance variables will have set methods. But anything that doesn't need to be changed, like a like your student ID, it will be final. And once the object is created, it will not have a set method, right? So definitely we need a set here because you may change the gross sales of the employee, or you may change the commission rate. Anything can change, right? So we do need the set methods. And again, don't forget, you should validate the set. In the set method also, you should validate your variable, the value that you input. So instead of repeating code twice, once in the constructor and once, I created a validate method. I did my checking there and I called it from both the methods, just because I didn't want to duplicate. Why should you duplicate it? Okay, so that's how you should go around it. So the set is required because definitely gross sales and commission rate of a commission employee may change over the time, right? And then there was a simple get earnings method. And notice this get earnings method is simply multiplying the commission by the sales. And the toString method, just to show you a few funny things, like you could put a number with it, you could put a minus plus sign with it, and so on. So I've shown it to you, and then I've kind of said, now you know that you can right align, left align, give it a width, and so on, just so that you know it can be done. And I had also given you a base plus commission employee. We had done it together last week, which was basically extending the commission employee. So now base plus has 3 parents, right? Let's see. It has all that belongs to the commission, it has all that belongs to the employee, and it has all that belongs to the object. So it can use any of the public methods that are available in these classes. It can use any of the public instance variables, which we usually don't go with. We always have private that are available, right? Object doesn't have any instance variables. That's okay. I mean, it just sits there. It doesn't inherit any instance variables from object. So further, in addition to all those 4 instance variables, name, social security number, gross sales, and commission rate. Now base plus says I need a base salary also. Objects of this class need a base salary also. So what do? We add another instance variable here. We make it private. We are sticking with data hiding. We write our constructor. We tell our parent, you do the 4 jobs of initializing it, and I'll validate salary here. Keep in mind, the parent has no clue about what happens in the child. So a parent cannot see the methods or the variables in the child class. It's not opposite. It's only the child who has the advantage of using everything. So it's only a one-way relationship. It's not a two-way relationship. Keep in mind. So the child inherits everything. The child can use methods. The child can override methods. It's not the opposite way, right? Though, like you would think it is, but it's not the opposite way.
So when you use the super there, the program automatically understands that they have to get the information for name and social security for employee and gross sales and commission.
Exactly. See, so when this is called, when you have a super here, it goes here. This is where it goes automatically. The call goes here, right? And the commission has a super, so the call goes here. So the employee does the name and social security number initializations. The gross sales and the commission rate are validated and initialized by commission employee, and the salary is done by the base. So super is just a call, like you are calling a method, right? So the first super takes you here. In this constructor, the super takes you to employee. Employee does its job, comes back. It's a call, it will come back. It comes back here at this statement. It does the validation of gross sales and setting and whatever. Then from here, it goes back here. Where here? At this statement. So it does its validate salary here and the validate salary says, right? So it's kind of doing it in steps. So it says my parent is doing it, why should I do it? Remember, the main advantage of inheritance, one, definitely you have a hierarchical structure which you want to create, plus reuse of data. Why would you reinvent the wheel? Why would you do that? Right? That's the main purpose of inheritance. Till now you were creating different classes. You used has a composition. You said, oh, this has it, this has it. I have a string. I have an array list. So you were using, your classes were using other classes. Now you're trying, this is also usage, but the usage is different. It's not a has a relationship, it's a is a relationship. Keep that in mind, right? So where you see, in applications where you see hierarchical relationships inherently, you just see them. Like, this is so obvious. Similarly in student could be an undergraduate, a postgraduate. In undergraduate, you could have a full-time student, a part-time student, right? So where you see this hierarchical structure, naturally, you will go with this. Though inheritance is very tightly coupled. It is tightly coupled because they're so related to each other. I make changes in employee, I do any changes in employee, I change a method name, I add a new method, I change the name from being a string to social security number from being a string to an integer. Everything that's under it will have to know this change, right? And it will change the data. How you call it, what value you pass, everything gets changed. Whereas in composition, if a method changes, I just have to say, oh, now that method is returning this value. So those are called loosely coupled. Compositions result in loosely coupled relationships, whereas inheritance results in tightly coupled. And tightly coupled is never is not assumed to be good. Why? Because anything that's tightly coupled means change in one directly affects the other, and then you have to make changes. But as I said, if it is inherent in the relationships, that's what works, then you just go with it. So you have to create a balance, right? Okay, so having said that, all we did was we added an extra base salary here. So the job of this class is to validate this, to set this. Since salary cannot be less than 0, I validated it here. I have a set method because salary may change. And I also call it from the constructor and I call it from the set. The rest kind of remains the same. But notice what I've done. So see how tightly it is coupled. It is saying get the earnings from my super and then add my base salary. So it is tightly coupled, right? It is. Now, for whatever reason, if I say, oh, the commission employee will get 10% more commission than the base, that it say, oh, now you have a different commission altogether. You have a commission rate, but you get 10% more than me anyway because you don't have a base salary. Then I'll have to change this. I can't use the get earnings of my super. I'll have to write my own formula, gross sales multiplied by commission rate. Because the other person, my parent, the parent of base plus has a different formula to calculate it. This is called tightly coupled. Now it is okay, they're doing the same thing, gross sales into commission. But for whatever reason, if the company rule changes and it says commission employees will be paid 10% more, then I'll have to make that change in their get earnings. If I make the change there, I can't use it here, right? So these are tightly coupled classes. But all it did was it called the earnings of, it says you are calculating it already, why should I recalculate it? And then you add the base salary and return it, right? This is tightly coupled. And then in the toString also, see how it's kind of taking the advantage of the toString of its super. It says, give me all the information that you already have. I'll add whatever I need and I'll give it back to wherever I am required. Right? So here also the percentage S is related to super.toString. You're calling the toString method of your super class. So it's all related. What I've done now is, just to save time, I've also created two more classes for you. Very similar. Come on. Open. I don't know, something is wrong with, oh, maybe my mouse could be wrong. Do you see an open here? I see a debug because I can't open it with my double click. Okay, there one opens. There it is. Okay, so here is my salaried employee. I added another class, keeping in mind this hierarchy that we were trying to create. Now, the salaried class should extend the employee class. So it has a name, it has a social security number, and what does a salaried employee have in addition? A salary. That's all they have. They don't have anything else. So we'll need another instance variable there, right? So now I'm creating this hierarchy, very similar to what you've done. So what did I do? I added another weekly salary variable here. Another instance variable. So now how many does this class have? It has 3 instance variables, 2 coming from its parent and 3rd user. Right? So a name, a social security number, and a weekly salary. There is no other instance variable because the object class doesn't have an instance variable. Again, it is a two-level one. From employee, employee gets it from object. So anything in object and employee belongs to this person, right? And it is becoming specific. These classes are becoming specific as we move down the hierarchy. Instead of becoming generic, they have more code, but they're becoming specific in their functionality. So you go from general to specific in inheritance. Okay, so what does it do? Same stuff. It takes 3 parameters, and you'll say, oh, sorry, 4 parameters. Oops, it takes 4 parameters, and it says, okay, I'll call, okay, so we'll make a change here. I didn't do that so that we could do it together, now that I realize it. And it has 4 variables. It passes the 2 to its parent, right? So the 2 go to its parent, the name and the social security number. For the weekly salary, it should do the validation itself here. Again, notice how I have a warning here. It says overridable call in constructor. So it's not a syntax error, but it is not recommended at all. It said, don't do it. Why? I showed it to you last week. If it is overridden by a child class and the child class changes its definition, we had havoc. Remember, name was becoming null and it was creating problems. So you may not even catch that error. Though you could say, I'm not foolish, I know what I'm doing. But you know what? Programmers are human beings. Mistakes can be made. So why even do this? So what I'm going to do here is I'm going to validate my salary. So I'm going to write a private method called weekly salary validated. Pass the weekly salary to it. And I'll remove this. I won't call it. So I'm going to alt enter, you told me, right? And I'm going to create it. And in that validate method, I'm going to take the code that is in set, remove the one that is in set, and put it in your validate. So my validate salary is ready. I'll kind of pick it up from here and just put it. I mean, it's again, it doesn't matter, but it's nice to have it where you can see it. I'll put it here. That's my validate weekly salary method. And I remove the call to set weekly. So notice what is happening. The validate is checking if the salary is greater than 0. If it is, it's setting it. Else it is throwing an exception. That's exactly what you want. And putting it in a private method ensures this method cannot be overridden. This method cannot be overridden. And rightly so. Why should weekly salary be overridden in a child? You can change your mind, right? Weekly salary is weekly salary, cannot be less than 0. So when you see inheritance, you are saying, oh, the child depends upon the parent, right? And if you say, no, it can change, then set method will be overridden, and that's perfectly fine. You'll say here the salary is less than 0. Maybe in your child you want salary less than 0 is an error, and salary greater than $200 is also an error. You can override set methods. Nothing stops you. As long as you know what you are doing is the main thing you have to keep in mind. So for whatever reason, if a child class is created and in there you want to change the validation, then you don't have to bother it here, right? Then you will just override it there. So now I call validate from here too, and also I call validate from my set method. Don't forget that, because otherwise the set method is empty right now. Oh, what did I do?
Just forgot.
Forgot something. I have so many. Somewhere. Okay. Set weekly. That's an else. So that's right. So set weekly salary. That's this. Oh, okay. I see what you mean. I don't know how I messed it up, but I did. There. Oops. Control S. It's Alt Shift and F, right, for format? Okay, there it is, formatted. So again, I didn't do this, but definitely we've already talked about it. I don't have a warning even now, so I've called a private method here. We've called a private method here to validate your salary. I still need a set method. Why? Because weekly salary may change, right? You may want to change it. It may not change, but you need a button. If it needs to be changed, then what do? I mean, I don't want to dispose of my old object, old employee, and create a new. Keep in mind that then that's the only solution. If you don't have set methods and you want to change something inside the object, what do? Kill the object and create a new one. That's not how it goes in life, right? That's what we do. You don't keep killing the old ones to create new ones. You change the old ones. Same anywhere, anything. You write an assignment, you don't say, oh, I'll start from scratch every time. You don't do it. You make changes to the assignment you are doing. Same concept. So you have that set method to change it. right? Similarly, anything that you take, you just throw away old things and create a new one, and then say, oh, let me copy the things that are okay and I'll add more. So therefore, we need a set method. So my salaried employee is ready, right? My salaried employee is ready. So it is extending the employee. Looking at this diagram, that's what I've done. I've extended the employee. And since employee was an abstract class and there was an abstract method in it, look at my get earnings. My get earnings is simply returning the weekly salary. That's what the earnings are for this person. No calculation, nothing. So I didn't make it join the other hierarchy. It was not related to the commission employee at all. It had no relationship. So I said, okay, you don't have a relationship, but you have a relationship with the employee. So I made it a child of employee. Okay. And kind of that takes care of it. And again, notice in toString what I've done. I've called the super toString. In this case, which one is being called? The employee one is being called. Super for this is the employee class. So you will get the name, you will get the name and the social security number, and you add the weekly salary yourself. Job done. Right? The last class that I've given you is hourly employee. So they're not very different. All I did was I didn't replace the set methods, and we thought we would do it together. So now the hourly employee, again, works on hourly basis. Right? So the number of hours worked multiplied by the wage per hour. So definitely its formula doesn't match anything else. It's not a commission employee. It's not a salaried employee. It's not a base plus. So it is an employee, right? So we go back here. I added two more private variables to it, a wage and an hours. How much do you earn per hour and how many hours have you worked? And I took it a double because you could be working 3.5 hours, for example, 3.5 hours, right? Same thing, I took some private constants here. Again, keep in mind, constants are a must when you want to work with numbers. So what I've done is this person's salary is calculated like this. If the employee works for 40 hours, then simply wage into hours. But if he works for more than 40 hours, then the first 40 hours is given a normal wage into hours work, and the rest he's given 1.5 times his wage. So therefore, I have that number called 40, which I've called overtime hours. Right? So anything beyond 40, he's paid 1.5 times. Till 40, he's paid 1. That's the maximum hours in a week. Now, those are not logical, but what I did was I took 24 into 7. Right? Nobody works for 168 hours in a week, but at least it can go beyond that. But again, if the company has a rule that an employee can only work, say, 60 hours, that value from 168, I'll change it to 60. So I don't use magic numbers in my code. I give them names that make sense. And then if you need to change a value, we just change it here. So if the maximum hours, so that's 24 into 7. A week has 7 days and 24 days in a week. So that's that number. If I start using numbers like 168, 40, or even 60 or 45 in my code, they won't make sense at all. So please use named constants in your code. So 0 or 1, 0. I've taken minimum hours to be 0, so it should be greater than 0, less than or equal to 168, and anything beyond 40 hours, overtime hours, has a different formula. That's all it is. So the first 40 hours paid 1, and 40 and 40 above 40 are paid 1.5. So you'll notice when I do the get salary. Now do the same thing here. Instead of calling set wage, please validate it. So create a validate wage method. It's very easy to do, right? It's not so tough to do at all. We just have to know how to do it. I'll show you another way in another program. It can return a Boolean value also. And we can use it here. I mean, it's just different ways of doing the same thing. And I'm going to write a validate. You can call it whatever you like. Hours, and I'll pass it the hours. And then I'll just create them here. Then I have to go and copy them. So I'm going to create a private, does not return anything. It's called validate wage. Takes a double, not D capital. This is just a, it's just a basic data type. And make a copy of it and call it, oh, what do I do? I don't understand. What do I do? I think there's something wrong in my mouse. Okay, and call it validate hours. And again, we could keep double wage here because it's just a parameter, but we never use names that don't make sense, right? And then we will remove these sets. These are both private methods. And then what happens in sets is you take your code from the set and put it here. That's how your wage is validated. If wage is greater than 0, wage is fine, else throw an exception. And I'm using illegal argument exception so that there is less work for me in exception handling. Right, so I've shown you exception handling, but it's not the end of it. There is another try with resources you could also do with try-cat. But I've done enough. You will see it. You will see again more of it in your other course. So that's your validate wage. And remember to call validate wage in your set method. Don't forget that. You can leave it. I mean, you can leave it empty, but you should not be leaving it empty. So there, what the set does, it calls it. Please go to your set hours and put this set hours code inside validate hours. And notice how I've said, if the minimum hours is greater than or equal to 0 and less than, I've just shown you a different way. This if else, I've just put it opposite. I mean, it's no rule which says, oh, you should throw the exception first and check the afterwards. I did the checking here first. I just find it more work because I have to put an else, but it's up to you, whatever you want to do. So if your minimum hours are greater than or equal to 0 and less than or equal to maximum hours, you're okay to go. Maybe a person didn't work any this week, so 0 is a valid value. Else you throw an exception. And notice, please, again, how I've used my named constants in my error messages also. Please don't revert back to using 0 and 168 here, or whatever the number. The whole purpose is lost then. So if you declare a constant, please see that you use it everywhere, including your printings and including your, I mean, not, we don't do printing, throwing your exceptions in your error messages and in your usage. Yes, Bradley.
I just created both methods, validate wage and validate hours, but in the public hour of the employee, when it shows methods, it still has the squiggly lines for the validate wage, validate hours.
So maybe you didn't put it the right name. I don't know. It's called validate wage. Maybe it differs from what you've called here. See that it has the same signatures and everything. It can't. If you're not doing it right, then it's absolutely something different, right? So validate wage has to be called with the double value. So there it is. Validate hours has also to be called with a double value, and there it is. And remember to call them in your set methods.
And we removed the set wage and set hours?
No, we didn't remove them. We replaced them with the right statement. We've done this 5 times now. We just call it.
I mentioned the constructor.
Yes, yes, you do. You don't do 2 jobs, right? We shouldn't be doing 2 things. It's just a process. I mean, you don't even have to memorize it. It's just a process. You should know what has to be done. There, right? So my set methods are ready. So see that you call the right things in the right places, and then, of course, remove the set methods in your constructors. Can do both. Should not do both logically. What's the sense of doing both of them? You're validating and then you're again calling the set to validate is useless. I mean, this is just common sense. Okay, there, my class is ready. So now I have another employee who is working on hourly basis. So a new variable was added, 2 new variables were added because this person works on a wage on an hour. And let's now look at, so the get and the set are just normal method. Let's look at the earnings method. So I've overridden it. So this is a concrete class now. Concrete class means that does not have any abstract method. All methods are concrete. Till now you've always been doing concrete classes. Now they have a name because now you also know what an abstract class is. Notice what I've done. I've checked. Are your hours less than or equal to 40? If yes, I just do the normal math, right? But if it is more, then what do I do? For the first 40 hours, I give him the wage or her the wage, whatever they have. And for the rest, I do my math. I subtract whatever from 40 from it, and then I multiply it by 1.5. I think the 1.5 should also go as a constant. 1.5 is overtime pay, right? It's your overtime pay factor. That's what it is. So you could do that. So let's call it overtime pay factor, right? So this overtime pay factor is a value. Take it from here and make it a constant. The 1.5 was, again, no magic numbers. They may make sense to us because we know what we are doing, but they won't make sense to people who are reading your code. And maybe to you after 2 months. Remember, software is not written and thrown. It has to be maintained over years and years and years. Therefore, we have new versions coming out. Like they have to keep whatever is going on. And people change. You may not be working in that company anymore, but somebody else will be. So we'll add it here. So these are ints. So we'll have to create another one. Oops. These are ints, so this was a double. We'll create another one, and again a constant. I called it overtime pay factor, and it's a double. Basic data type double, not your class double. There it is. So create another constant. So I forgot my 1.5. When I read it, it made sense because I knew what it was, but again, now it makes more sense, right? So now you have the liberty. If it says, oh, they will be paid 1.7 times more, or the overtime hours, anything beyond 50 is now overtime hours. Maximum hours definitely cannot be 168, should be something like 60 or whatever, depends, whatever the company is doing. I just made a 168, right? Just multiply 24 into 7, which logically is not correct. But who knows? I don't know. You people work. I don't work that many hours a week because we do sleep. But anyway, I just put it there. But it can be done. You can just change it at one place and you don't have to bother about whatever is going on in the rest of the class. So please see that you use named constants and then use them wherever you're doing any kind of executions or even when you're throwing error messages. The only place where you can't use them, where they're not replaced by its value, are in the comments. They don't get replaced in comments, right? In comments, you'll have to write whatever you want to write. I mean, logically, because remember, comments are not executable statements. They're just comments. So that is where you can't use them. And don't use them because it won't make sense, right? To a user who's reading your code, Java doc comments, he sees something like min hours and max hours, and he doesn't, or she doesn't even know what it means. Don't use them in comments. My class is ready. So now I have this hierarchy, right? My hierarchy is ready now. So we learned inheritance, how to do inheritance. Now, the sub-effects of inheritance. What can I do? What can I assign? Can a superclass variable become a base class, a subclass variable? Can a subclass variable become a superclass? What is polymorphism? All these concepts are what I want to show you now. But hopefully you've understood inheritance. Are we clear about inheritance, right? So the next assignment that I'm planning, I'm working on it now because I know you're busy with your RD, so I have a little time with your relational database. I'm going to ask you to create a hierarchy for me. And I can't leave it to you because then they'll be valid. So I'm kind of picking up an example where it's not too mathematical because not every one of you is mathematical. I was thinking something like shape. I may even end it up, but with shapes, there are a little problems because when you start working with shapes, then if I say, okay, now every shape has an area and so on, then it kind of becomes a little mathematical. Right, so I created this for the assignment and now I am backing out a little because it's quite mathematical. If I start saying areas and perimeters and so on, to some of you it will make complete sense and to others, the math itself will become heavy for you. So I want the emphasis on the inheritance, not on the code. Like my aim is not looking for code, my aim is to looking that you know how to create an inheritance. So I'm picking up other examples, but that's how I started. Then I thought, So I've been spending a couple of days thinking of a good assignment. It's not easy.
We need to focus on the inheritance, like
yes.
Which classes are connected.
Definitely, that is inheritance, right? That's what inheritance is. So the assignment should come to you. Give me a couple of more days, and then I'll give you the assignment. And it will definitely be on inheritance, right? And I'm marking the other one. I've started marking it. It's not that bad, but copying and pasting is not doing its job very well. Method names have not been changed. Messages inside methods have not been changed. So all methods are saying find by ID, whereas they are different. One is find by ID null, find by ID empty. So I have to kind of look at code again. So I think it would be easy to mark, but when I start marking it, I have small things that are not so good, right? If all your methods are called the same, I mean, all you say is ID1, ID2, ID3, then it's so difficult for me as to what you're checking, right? What are you checking in this 1, 2, 3, 4? And then if you forget to change your system println statements inside the method, each one of them is saying find product by ID, find product by ID, then I don't know which one is throwing an error and which should not throw an error, you see? So you guys become very careless when you do your assignments. In the long run in your life, it won't help. You have to be perfectionists, keep that in mind, right? You have to be, you just can't do it. But anyway, it's your life, your students. You will learn your good time. You will, hopefully. We all learn, right? Okay, so that's a good example of inheritance. Notice what I've done. I have a shape. Anything is a shape, like any general shape. And then under shape, we have 2-dimensional shapes and we have 3-dimensional shapes. Under 2-dimensional, the common ones that we usually know about is circle, square, and triangle. In 3 dimensionals, we have sphere, cube. These two are common. The tetrahedron is not so common. but these are three-dimensional. So each one of these shapes has an area and has a 3 meter, right? The sides are different. Circle doesn't have sides, but square will have 4 sides, triangle will have 3 sides. Not every shape has sides. So there is a lot of thinking as to what should be the instance variables and so on. And then again, sphere, cube, they don't talk, they have sides, but they have a different number of sides. So number of sides could be a variable in your shape, and then you give it a value. I mean, it has different values in each of the shapes, right? So it's kind of a little thinking, and then areas and so on. Even if I give you formulas, maybe. So that's one that I'm working on right now, and there's another one, accounts, which is common, right? All of us deal with money. So you have accounts in banks, so you have savings accounts and checking accounts. So that's the other one I'm working on. The one that is much simpler and easier to do, I'll give it to you. Right? Let me work on it first. I have to make it work first before I give it to you. So I'll give you something like this. I'll give you a diagram and I'll say, here, create this hierarchy for me so that you have something. Since the time is short, I can't say, think about instance variables yourself and do this. I'll have to kind of make it bound. That's what happens with assignments, you see. I mean, I have to bound them, because if I don't bound them, then I can mark them. It becomes difficult. So we can't bring real time directly into our assignments for this simple reason that we have to mark them. I could say, okay, 2 instance variables in each class. Somebody may come up with very good instance variables, number of sides and something. And some may just say color or something, which don't make a lot of sense. You know what I mean? So it kind of becomes difficult. Anyway, that's not your job. That's my job, right? I have to think of assignment. You just have to do it. And you think, oh, she just has to make an assignment. We have to do it. Anyway, having said that, now let me show you polymorphism, a corollary of inheritance in Java, right? What does it give us? And let's talk about downcasting and subvariables and so on. So now write a tester with me. So I didn't give you the tester because I would like to discuss it while I do it. So we do have a class called employee inheritance.java. You can use the same class that will become your tester, right? So you can make a note here. This class tests the various classes in the hierarchy, right? So, I mean, usually we call it tester or something. And keep in mind there are 2 ways of testing. One, your BlueJ framework testing. Oh, sorry, BlueJ, UnitJ testing, right? It's a framework. You test your classes. But at the end of the day, after you've tested everything, you have to create an application. So this is more like creating an application rather than testing. We test our things in it, but when it eventually works out, it will be a complete application. You may have a menu, something is chosen from the menu, and so on and so forth. But it's the same process. Okay, so now let's kind of go ahead and start doing a few spelling hierarchy.
H-I-E.
H-I-E?
Yeah.
I before E except after C. Yep, thank you. The rule is I before E except after C. Whenever you have an I or E together, you put I before the E. Okay, so let's do it. Okay, so I'll start off. So keep in mind, abstract classes cannot be instantiated. You already know that. So you have that somewhere. I'm going to change it. If you want to keep your old stuff, keep it, right? If you want to keep your old stuff, keep it. Maybe I can do it from here. There. So I leave that just so that you know. Okay. Otherwise, regularly you can use them as types in your programs, and I'll show you what has to be done. Okay, so let's start. Now, what can you do with particular employees and so on is what I'm going to show you. I'm going to first create normal employees. We have a commission employee, we have hourly and so on. We have all of these. Oh, you know what? At least we had those names there. Just to save myself some work, okay? Okay, so I'm going to create all kind of employees. Not yet complete, but we'll go one by one. Okay, so if you want to follow me, since I already have data, you can go with me, but it depends on whatever you want to do. So we'll go, I just picked it up from somewhere so that I didn't have to think about it and not worry about what is going on, okay? Just so that you remember, it's name, social security number, gross sales, and commission rate. Okay, that's my first person. I'm creating a base plus commission employee, and I'm going with, again, you can replace it with whatever you like. My aim was that I don't have to waste time thinking about all these irrelevant values. The extra instance variable in a different sequence was that salary, the base salary, right? So I've given this person a base salary of 300. Let's create more employees. The sequence is not important how you create them, right? I mean, because we have 4 classes, I'm just creating them. And we just now added 2 more classes. One was called the salaried employee. And again, the names are not too good. CE, BCE, and SC are not so good, but they work for me, then I can remember them. Okay, let's create a new salaried employee. And they need a name and so on. So it kind of works for you. We'll go John Smith. Regular, right? I'm just doing regular. Then we have the social security number, which you can put of whatever. And they had a salaried person. So we'll just go 800, weekly salary. That's my salaried employee, right? And then I have a 4th employee, and it was called hourly employee. And you can call it HE. And the hourly employee needed a name. Needed a social security number. Needed a hourly employee wage. And again, you can put whatever you like. I don't know what the minimum wage is right now. And then the hours worked. Right, so my 4 employees are ready, as if you would do it for anything else, right? They're just normal variables. Now, just so that we know things work, we are going to print each. You know what? I can actually call it. Let's call a display details method and pass it. Okay, now let me show you what I can do. Right? This will be neat to show. I'm going to create a public void, a private, not public, sorry. It's a helper method. A private, oh, it has to be static because it is being called, returns nothing, is called display details or display employee details, just so that it makes more sense. And notice the parameter that is coming to it. And understand what I'm trying to do. The first advantage of inheritance. I can pass it a CE. I can pass it a BCE. I can pass it an SC. I can pass it a look at the first use of inheritance. Since every of these employees, BCE, Cs, all commission, base, salary, hourly, they all is an employee, you can pass the reference of a subclass object into a superclass object. It's like an assignment. So this means you can assign a subclass to a superclass. You can do that. Why? Because every of these employees is an employee. The opposite is not true. It can be done. It is called downcasting. I'll show you it can be done, but it is highly recommended that you know what you're doing. It can be done, but this is what you're doing. Right? Now, what am I going to do? I am going to say, oh, I want to show the details. All I'll say is this. I'll go system out println, and we'll see if it works, okay? And what is happening. And I'll say E. I'm calling the toString method. Right? I'm calling the toString method, and also I'm going to show the earnings of this person. You can do a printf if you like. Right? And I'm going to, in a different line, because I don't know how the others are looking, I'm just going to say earnings, and these are weekly earnings. Remember, they're all weekly earnings that we're working with now. I mean, it depends on what you want to do. And a double was coming back. So percentage, you can say 10.2 if you like. Nothing stops you. We've never used a figure before the decimal. But 10 means give me a total space of 10 columns. Right? That's what it means. I just say 0.2 always because I don't bother about the front. When you say 10.2, it will exactly give you 10 spaces. Use it, sure. If you don't use it, you will have leading blanks. Okay, so it depends on you. But just to show you because you haven't seen it before. So I'll go $1 here. And then I'll say percentage 10.2F for float. And we will call the E's get earning methods. Every one of them has a get earnings method. And it doesn't, oh, come on. That is happening in my display employee details. So the first call is going to go E.toString, right? Because when you don't say anything, you could call it employee if that makes more sense to you. You can call this as employee also. I mean, just E. And then get the earnings. See what happens. Think about what happens. When you call it with the first one, commission employee CE, E is assigned the value CE. That means a superclass variable can be assigned a subclass reference. It can be done. There's nothing wrong in it because the hierarchy says a commission employee is an employee. A base commission employee is an employee, though indirectly, but is an employee, right? Same for salaried and same for hourly. And this will work, right? So this is the first use of your inheritance. You can assign. So if you want to kind of put it for yourself, you can assign. It's kind of an assignment, right? You can assign a subclass reference because they're objects. We call it a reference. Spelling is wrong. To a superclass reference. Make sense what I've said? Right? So CE is assigned to E, BCE to E, SE to E, and HE to E. Just because of that inheritance. Just because of this inheritance. So now if you would like to see it, right? Let's see what happens. I'll add more things, but right now this is what I've shown you, right? So let's try it. Let's save this and let's try it. And I should see 4 of them. I'm not sure. Should come in different lines. You know what I'll do just to kind of make it a little pretty. And of course, more than pretty. More than pretty so that I can read it properly. I'm going to kind of put each, sorry. We've done it 4 times. The first one is CE, then the BC, then the SE, and then the HE. It calls display employee details here. This method is called, right? Of course, after the calling, where do you come back? To the next statement, right? It's just invocation of a method. It calls, comes back, calls, comes back. Always you come back to the next statement following the call, right? Okay, so let's try it. Give it a go. And let's look at our output. Now, however neat it is, I forgot my percentage N, right, for my system out println. But that's what happens with that. Okay, so see what is happening. This is the first person. Notice how it has a gross sales and commission. This was with the CE person, the commission employee. Earnings, and then we, oh, am I showing? Oh, I'm showing it there. I'll have to remove it from there. Oops, because the earnings are different. We'll have to remove it. Somewhere I have a statement which is saying earnings. We'll remove it from it. Then here, we will say a base salary and then earnings at the end. So this is the second person with a base salary of 300. And this is the third person with the salary and so on. Now, if you also wanted to print something like commission employee, base plus commission, we can add those headings too. We can add it, we can pass it to this method and it will put it on the screen. We can do that. We can try it. Not try it, we can do it. Okay, so a few untidy things to be taken care of first. Please put I did. Oh, I didn't do it after. That's the problem. Percentage N at the end also. One job done. So now these lines will come on different lines. Sorry, wrong place. Thank you. Not here, but here. Inside the format specifier. Inside the format specifier. That's one job, right? So that will take care of the untidy here. Now these earnings, I think I was showing it in my basic one from my commission. Go back to your commission employee. Come to its toString method. Remove it from here, please. So a heading is going and a value is going. Two things are going. So please remember to be very careful. Two things are going. Percentage %2f and percentage %s. Two things are going from the end, right? Be very careful because otherwise we'll start having problems in this format. So percentage %s and percentage %2f, I'm removing from the commission employee toString method and also removing at the end. There, that's gone to. See, oh, comma gone here. Okay. So now I won't have that repetition. I don't want to have that repetition. Everybody's earning is different, right? Gone. I write the common things. I write what the common things is. So name and what, oh. Okay. No. Okay. Yeah, we are good. We are good. Remove the earnings, right? Now what else? What else was a little untidy? Oh, not untidy. It would be nice to see. Are we okay? So from the commission employee, I've removed the last two and I've removed the last two from here. Now in your data, if I could also say what kind of employee this is, it would be nice, right? So we can do this. Pass two parameters to it. So commission employee, this is one way of doing it. I'm not saying this is the only way of doing it. Pass a string and then pass the employee. Right? So pass the string and pass it. So we'll take a string and we'll call it type and we'll pass an employee. So this is base plus commission. This is one way, maybe not the best way. I'm repeating, maybe not the best way. Maybe it would be better to put it somewhere in class. I'm just doing it here so that at least I can take care. The third one is here. This is a SE, is a salaried employee. You know what? Maybe a better place would be in the class definition itself, in the toString methods. The first one will create a problem. The commit, no, I can do it. Oh, that when I say toString, when I do a super, then I'll have the same name. Yeah. Okay. I'll think of something better, but right now this is what is coming to my mind. This was a hourly employee. So what have I done? I've passed a string to it, which makes it a little neater. And then what I'll do is I'll kind of print it here. I'll print its value here. So this is println. Println does what? Okay, so println will not do it. I'll have to break it. I'll go printf. I'll go %n. Oops. And it is a string. So after something, I'll just put a string here, %s. And again a %n. And then I'll put that string that you gave me. And it was called type. There. So now in the heading, it will say the type. Right? Looks neater. Let's see how it looks now. And this, of course, we should go a little more. And it's always a good idea to kind of printlns, we are okay. With printfs, you have to be very careful that you take care of your %ns. Let's run it now. Let's see if it is neater. Okay, let's look at it now. See what it says. Commission employee, right? Then it says base plus commission employee. Then it says salaried employee, and then it says hourly employee. And it's neat enough. I see a few extra lines between weekly learnings or whatever, but otherwise it's fine. So we'll have to just see we had an extra line here. Then we're leaving some space, which is okay. Leaving some, oh, weekly, what's happening to salaried employee now? Salaried employee is showing it. We'll have to take care. We'll have to remove it from here because the weekly learnings are same as this. What about the last one? Last one is okay? Yep, hours worked. Yeah, so we just have an extra one here. I'm showing the weekly learnings in salaried employee. Just remove it from there.
Wages and hours.
Wages, the last one, spaces between where? You mean this?
Yes.
Oh, you mean between the 40 and the hours?
The space between the
Oh, the
and the hour itself. Yeah, this space.
between, oh, you mean this? Oh, yeah, I see a semicolon here. This should be my size of my string. That's what it is. We have to change that too, if you want to, right? Yeah, yeah, a little bit of untidy. But notice this. I wanted to show you this. This is what is happening with 10.2. It's little untidy. Why? The $sign comes and you say, give me 10 spaces. So it's only taking 5, the rest 5 are blank. So this is looking odd. But that's what happens with a size before the 0.2. So definitely we should remove that. Right after the $, right? We should definitely remove it. Now I see extra, some double quotes but I'm not so worried about those. Those are small things, right? 2 colons and so on is not a big deal. So that means the earnings, I shouldn't do it with a 0.2f. So I'll remove this 10 and we'll be okay. But I wanted to show you what the 10 does. Right? 10 gives you a total space, but then it starts looking. But that's what size does. When you say 25s, you're saying give me this much size. That's what you do. Okay. Okay, so that takes care of one job. Now you know that subclass, and neaten up. It's not a big deal. Now you know that we can do this for the simple reason that a subclass can be assigned to a superclass. Right? This is happening because you've done inheritance. Now let me show you something else. Polymorphism. And keep in mind, see, it was smart enough. When you passed it a commission employee, it called the write to string method and the write get earnings. It knows that. Why? Because it is actually, when it's saying e dot get to string or it's saying e dot get earnings, it knows what kind of e it is and it will go to that class directly. If that class doesn't have it, then it will look at its parent. Right? It may happen that it doesn't have it. I mean, we have overridden it, so we are okay. But if a subclass doesn't have a method and you call it, all it says is, oh, I don't have it, I look in my parents. That's all it does. The parent says, I don't have it, I will look in my parent. Which is okay, which is perfectly fine. Okay, so that's possible. I mean, both our methods were actually overridden, so we see answers. But you can definitely call methods that are not overridden. For the simple reason that it belongs to the parent. Like try doing it. Try calling the set or the get name, which is in your employee class. You can print it. It will always use the same method get name from the parent class. Subclass objects can call methods of the parent class. That's all about inheritance. The opposite is not true, right? But a subclass can call methods of its parents. Right? It's not a big deal at all. See, I'll just show it to you, just for the heck of it. So you can make a note. Subclass objects can call methods of superclass or superclasses, whatever makes sense. It may not be present in its, but it can be. So if I want to do just for the heck of it, I'm showing you. Now I say CE dot get name. Commission employee doesn't have a get name method in its own class. It doesn't. But what will it do? It will use the get name of its parent. It will. Right? Any methods that are available, you can use them. Any one of them, get name, get social security number, with any of them, really doesn't matter. Here, try to do this. Use it with BCE and get the social security number. Make sense? Like that's kind of obvious, but hope maybe I should kind of write it. There it is. Here are some examples. Right? So what happens? CE, you call get name with CE. CE is a commission employee. It says, oh, I don't have a get name method. What does it do? It goes to its parent and the parent one will be called. BCE says get social security number. BCE says, I don't have one. It says, it goes to its parent, which is CE. It says, I don't have one. It goes to its parent and says, there you are. And that's perfectly fine. Make sense? So that's possible. That's logical. The ones that we've written, it was smart enough to go to that particular class, and it is. That's all about inheritance and do it. But this will work if you do it. Just so that I show it to you. If you kind of go up, see here, Sue Jones and 5678. It's coming from the get name and the get social security number. In one, I said CE because I wanted to show you one level of hierarchy. And the other one, I said BCE because I wanted to show you, oh, it doesn't have it, go to its parent. Doesn't have it, go to its parent. Right? So inheritance, that's inheritance working. Kind of think of as an inheritance like normal inheritance. If you inherit something, it belongs to you. So you can use it. So these are just examples, okay? And then this one says that you can assign a subclass reference to a superclass. What is happening? CE is going into E. BCE is going in. BCE can also go into CE for your information because it has two levels, right? So BCE can be assigned to an employee object. BCE can also be assigned to a commission employee object because both of it are its parent and grandparent. Okay. Now I want to show you polymorphism. Though Like this is also polymorphism, but in a different way. So what is the meaning of polymorphism? Poly means many, and morphism means implementations. There are many implementations, right? But it knows which one to choose. Even if there were two implementations, now keep in mind, suppose the parent class has an implementation, parent class has the toString, or suppose the parent class has an implementation toString, and the child class also has toString. It will first look inside the child to see, does it have an implementation? Yes, it will use that. And if no, then it will go to expense. That's what is happening with toString. That's exactly what is happening with toString. There is a toString in employee, there is a toString in the child. So it uses the toString of the child. So if it finds it good, if it doesn't find it, asks the parent. Of course, if the parent doesn't have it, it's an error, but otherwise, that's how it goes. Okay? So polymorphism means many, poly means many, and morphism means implementations, right? Forms. It has come from forms. Forms means implementations. And that's how it is working. It's smart enough to do that. Now, just to show you, you could also do this, though you've kind of seen it indirectly in this method. You can even do this. I create an employee array, right? Oops, so sorry. I create an employee array. You can call it whatever you like. I'm going with employees. And you know how to do it. You go new because it's an array. And you can initialize it right here. I'm not initializing it right here just because it's too much space. So I'm saying give me an array of employees of size 4. Right? You've used arrays hopefully in your first semester. So you say new employee, 4 means give me 4 of these. If you don't want to give a number here, you can initialize it right here. That can be done in arrays too. And then you don't give this size, but then you initialize them right here. You have to say new whatever. For me, since it is so big, I'm kind of just going, it's not big. I mean, I could do it there. I'll show you both ways. It's not a big deal. Let me show you both ways. It can be done in 2 ways. If you've forgotten how to do it, I haven't used arrays myself for a while, but if you don't give a size, does it also work like this? No, you can't leave it empty, right? But if you initialize it right here, which I'm just showing you, I'm going CE, comma, BCE, comma, SC. I'm just following the same sequence, doesn't matter. I can also, it doesn't like that too. I thought this is how you do it. What is it saying? Variable employees is already, oh, that's what it is saying. Okay, right? I was just showing you 2 different ways. One way is this. So if you want to leave your array, you can. Remember, array is a static data structure. You have to ask for, give me these many spaces. You have to do that. In arrays, in array list, you don't have to. So in arrays, an array is a contiguous block of memory of a fixed size. That's what an array is. That's how it is different from an array list. So you have to say how many. If you don't say how many, it will complain. So there are 2 ways of doing it. I've shown you both ways. This is the first way, right, which is more lengthy. But if you want to leave this, you can leave this empty. And we know why, because during compilation, those many spaces are given to you. So if you don't say it, it won't let you compile it. So that's a compilation error. So if you want to avoid, or if you not want to avoid, I mean, there is another way of doing it. You can leave it empty, but then you have to initialize it right here. And notice my initialization. Is my initializing making sense to you? Because it is an array of employee objects. Because it is an array of employee objects, I have to pass it employee references. And CE, BCE, HE, and SE are all employee references. Or I can also show you in another way. I'm going to do this just so that you see it, but see how can I do it? Same concept that we just did actually. To the 0th element, I can assign a value. To my first element, I can assign a value. To my second element, I can assign a value. So this is a lengthier way of doing it. I wasn't sure if you remember how you can do it other ways. And to my 4th one, which is starting from 0, keep in mind, I'm assigning the value SCHE. There. That's a lengthier way of assigning values. But I mean, if you need it, you need it. Now, same concept. A subclass variable reference can be assigned to a superclass. This is allowed. right? This is allowed. But what is not allowed is this. You'll say, oh, employee 0 is a CE employee. Can I use a method from CE? Because CE is an extra method. Remember, get gross sales, for example. Can I do that? Or can I say get earnings because CE has an earnings? Can you do that is the biggest thing. Let's see now what is happening. Okay, now if you do this, I've just assigned it to my variable. Now, if you do this and I want to just spit out the same thing, I'm going to use my enhanced for loop. I hope you remember the enhanced for loop. Bring out one employee at a time from my employees. Oops. Or for each, as you call it in other languages. So for enhanced for loop does what? You can use it in an array also. You can use it with any list. It picks up one element at a time from employees and puts it into the variable on the left hand side, which is whatever it is, right? I've called it E. And then if you like, I mean, I could call it, but I'm just, since I've used a, I can do this. Same thing I did first, but instead of calling the method, since I have it right here, I've just to show you that I can do this. Right? I'm just doing a printing. Again, you could make it a little pretty and so on. And make it a little like whatever you want. But I'll show you what do I do? I don't know the person's type. What do I do? How do I find out what person it is? But I'm going to just run this for you first. So in the first 4, just, yeah, I know it is a little untidy, but that's okay. So we are looking towards the end, okay? So here, these are the 4 persons. I have the first employee, Sue Jones, then I have Bob Lewis, then I have John Smith and Karen Price. No, there's something wrong. How am I seeing a heading here? Oh, my hourly employee has a heading, guys. In its own toString method, it has a heading. That's, I'm thinking, how do I see it? Can you go back to your hourly employee, please? And in the hourly employee, can you remove the heading? It has a heading here. And the spelling is also wrong. Remove that heading, please. That's why we see it. I didn't know I had kept it there. But anyway, that's not a big deal. Okay. So the hourly employee had a hourly employee heading, therefore it's coming up. So that's okay. So let's come back to where we were. Therefore, but the output is right. There's nothing wrong in the output. If you kind of read it, it's perfectly right. So let's run it again. And there they are, the last 4. As I said, not very neat, but it works. It will work because all I'm doing is I'm again assigning a subclass to a superclass variable and do it. Now let's look at what can be done and what can't be done. Now you say, what if I want to say commission employee with it? How can I handle it here? Like if I wanted to print my type also, I can use a switch statement and do it, but I'll show you a different way just because it's less time consuming. Right now, what can't I do? So I have an employee 0, which has CE, a 1 that has a BC and an SC and HE. Now suppose I want to increase the salary. Remember you had done this in your first assignment. I want to increase the salary of, you can do anything, of what? Of the base plus, I mean, that has a salary, that person had a salary, and the of BC, I'll just say BC here, right? Suppose that's what I want to do. I want to increase his salary. Logically, this is what I would do, right? Logically, this is what I would do. I could go BCE dot and say increase salary, but I want to show you I cannot do this. I cannot do this. Employees 1. Oh, I don't have it. Logically, you will say, oh, this employee is sitting at the first position, right? He's sitting at the first position. Let me set the base salary. Remember, it was called base salary. I think we'll check the method to get it. I'll just kind of just do a little math. I want to show you that it won't work, and I'll tell you why it doesn't work. I'm just going to say $100. for the heck of it, or $1,000. Right? Bring your mouse over it. What does it say? It says, I cannot find this symbol. I cannot find the get set base salary. You'll say, oh, don't you have it? Let's go back to base plus commission salary. Don't we? Oh, it's called set salary. Okay, that's my first mistake, of course. So let's go back here. It still says I cannot find it. You'll say, what's wrong? Employees 1 has a BCE, right? Employees 1 is BCE. There is a set method in set salary method for that BCE employee. Why doesn't it do it? It does not allow it to go the other way. A base commission employee is an employee. That's okay. But is every employee a base commission employee? No. Employees 1 is a parent. If you look at it, what is the type of employee? What is your type of array? What is the type of your array? Your type of your array is employee. An employee is a superclass. A superclass cannot use methods of a subclass. It cannot. The other relationship is only one way, I told you. It is not both. It cannot do it. You say then what? That means I can't use an array. Array is so easy to use. I mean, instead of declaring different variables, I just create an array and I know that I can put all my employees inside it instead of creating a commission employee and so on. I could have just done a new commission right here. I'm using my CE, but I could have said new commission employee, new this employee, and I was fine. I just used CE because it was already there. But I can do a normal statement. I can do a new commission employee statement here. I can do it. Nothing stops me. I can go new commission employee, and I can just do it like a normal thing. Just so that I show it to you. I can do this. Nothing stops me. These are valid values. I can make that assignment. And that gives me a little bit of flexibility in writing my code. I just say, oh, every employee is an employee. So just let me create it of employee thing and I'm okay to do. But I can do this. So I cannot do this. So I'll bring back to what I was just because I could do this, but I'm sticking with this because my data is already there. I cannot do this. You cannot use. So you can make a note for yourself. You cannot call a subclass method with a superclass reference. You cannot do it. That means I'll kind of take this out from here and put it here and can do this. You cannot. So what do I do then? I have this array. This array has all my variables. Now I can't call the set salary method from employees 1. I'll give you a break. I cannot call the set salary method from employees 1 because employees is an employee array, not a base commission employee. Then you say, oh, that means the whole purpose is lost. Like, can't I do that? Can't I just keep it in an array? You don't want to. Suppose all the employees, there are many employees in an organization. Where would you keep them? In an array or in an array list? But you can't. Then what do you say? What is the type of the array? Because they're all of different types. What will you say? My array is of type employees. And only then can you do it. But if you can't do this, then how will you get around it? And that getting around is called downcasting. We'll take a break here and then I'll come and show you. So you cannot do this, but there has to be a solution. There has to be a solution and it is called downcasting. So what is downcasting doing basically is it's called downcasting, though employee is more general. It's called down because you're coming down the hierarchy. You're trying to change an employee into a base commission. So therefore it is called downcasting. So it is not recommended, but if you need it, not recommended means you should know what you're doing, but if you need it, then you do it, right? So we'll take a break here and then I'll come back and complete this because it will need a little more, 10, 15 more minutes. Okay. And then if time permits, I have to do something else. Okay. So we'll talk about more of this. I'll show you how to do it.
Yeah, just have a few questions to ask you when you come back.
Very good.
You can come back to your
The
last one.
tomorrow.
Not this one, in the main class.
Expensive.
In the testing.
I said 716. Right in that kind of
You're running the-
Mine was a year or so, so.
There is, your gate earnings was a problem.
He wants $600. He's a better computer.
No, we don't have, I just showed you what we did. Yeah, gate earnings has one.
I am deep.
That's a good one.
Okay, so that is which one of these, who's that's two?
Yeah.
Which
I
one
don't
of
know,
you
but AMD always ends
commission plus, okay, so something.
pretty fair.
30 is too much, yeah. So 30 means you are giving me 30.
We have like.
So if you just say percentage yes, it will come towards you. Right? I was just showing you, you could use numbers. Right? You could do. Show me that. Something.
I know SSD.
Percentage went up. There it is. Only 30 years.
And,
Now, oh,
Yeah, I was gonna say, where's video?
Rating salary. No, 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 no.
Oh,
So let's get a jack up
You
the
sure this
price,
is the
right?
right, no,
Why?
jazz 1, jazz 2.
That's $300, you can spend like at least two something on the graphics.
Jazz
Yeah.
2. Jazz 2 is base
I know,
percentage.
all that stuff with fees, they don't know.
Show me the first one, give it back.
Yeah. There.
Oh, this tab.
Come on, right?
Yeah, the tab is what it is creating the problem. But then if you want, what are we trying to do? Super, it will show you in one, and then, so why is it going to a new line then? It is not. Oh, that's it, okay. Yeah, and then you want to put it on different line. Yeah, this is all what you are doing, so it's just following you, okay? Remember, you are the boss.
Also, I'm thinking about spending 1,700.
Yeah, yeah, then that's not bad.
Because I still, my budget is maybe $600. Yeah, maybe more than that. Wait. Or 600. Yeah, $600.
Olha, posso fazer primeiro? Eu tenho uma primeira e última vez.
Eu fazia 2 dias e meio, eu tinha feito, eu tinha mais guardado já para mais de mim. Divulgação. Ai, minha mulher, pacativa. A faquinha dele. Agora, comprar, pegar um novo. I'm only 15 years. Sorry about that. That's important. But yours?
Yes.
I just have a couple of questions to ask. Basically, when I was trying to add the name for, when I was trying to add the names for the display employee details, they came up with errors when I included the titles.
Hold on. You're saying I'm going to call these details in the string and this. Did you change the method in your? You didn't change it here, so it says I'll pass it two parameters, but you're only passing it one. Notice my method at 57. It has two parameters, not one.
String type.
You should be able to figure out these things by yourself till now, right?
Right. And basically for the commission employee, which two did we get rid of? I remember the one thing we had to get rid of, but not the second one, right, the two string overrides.
Figure out yourself, Bradley. What's the big deal? There was a heading and there was a value. I removed the two things from here and I removed the two formats from here. Like these are small things. This is nothing to do with, like, it's just, I just removed the earnings.
Okay. I'm sorry.
No, it's not sorry. You have to figure out these things. Like these are really small things now, right?
Well, I wasn't sure if there was more to it than that. I wasn't paying attention and I was trying to figure out the class while getting rid of any typos. But thank you.
We'll wait for another minute and then I'll start, okay? 12:45 I'll start. Okay, don't forget, so, I mean, I've shown you a few things, but before I go there, don't forget you can this is just normal Java that you've been doing till now. Without assigning to anything, you can always go CE, like you can just call it the toString method. Like this is normal, like you've just created some variables and you're calling its methods, right? So that's, I didn't even mention it because like, you know that it can be done. But just so that you don't forget, I'll kind of put it here. And if you would like to just do normal printing off with the individual variable, like this, you can go this, and then for the second one, and then for the third one, and then for the fourth one. Like this is just not, this is nothing different from what you've been doing till date. I didn't bother to show this one because this is regular, just regular Java, nothing to do with inheritance at all, right? The regular printing. Of course, this can be done. I mean, this is just regular printing using the objects. So I'll just put it here so that it makes sense that you have it. So if I was using normal 4 variables, CE, BC, I mean, no inheritance, I'm not even thinking about inheritance, then all I'm doing here is I'm just printing them out. But when I showed you this, I'm basically assigning a reference, and this is polymorphism, right? You're kind of saying, oh, I'm passing CE to an E. So now here is where we were stuck. So if I want to use an array to keep all my employees, and then definitely I'll use an enhanced for loop or a for each loop as it is called in different languages, then I can do something like, oh, employee 1 is a BCE, so I should be able to set its salary and change it. I can do it. But there is a way to do it, right? So what you can do is when you are working with a array of employee objects, and those employee objects can be anyone from your hierarchy, you can always check, are you the one? And this is how you do it. What do? You check if. You're basically asking the employee, are you a base class commission employee, or are you a commission employee, or are you a hourly employee? And the method that you use is not, it's not a method, it's instance of, it's an operator. It's not a method, it's an operator. So what I'm going to do is I'm going to say if E is an instance of. So instance of is an operator that maybe you haven't used till now because we never did inheritance till now. So I'm saying if this E is an instance of, write your complete class. Oh, wasn't it called base plus? What was it called, the class?
Base plus commission employee.
Yeah, it was called base plus. Why is it saying no? Oh, no, it's not. This here it was wrong. The off was wrong. I was writing it using method, like not an operator. So it was using the same convention. So it didn't recognize instance of, right? So instance of is an operator. It's not a method, of course, right? And I was just using the method convention. I went O capital. So instance of is an operator like your other operators, plus, minus, and so on. It's an operator, and all it does, it checks, are you a base plus commission employee? And if you are, then let's try to do this. So this is what you'll have to do when you deal with an array of employees or an array list, any collection, right? You have to check, are you the one that I want to work with? And you will have to use downcast. Right. So again, as I said, you should know what you can do it. You can't just do this. You can do this something like this. You can't say, oh, let's try something. You simply can't do this. Oh, come on. I'll just take another one. Base BC. Oh no, I've used a BCE. I'll just call it BCE2. That's what happens when you don't think of good names. Right? I just can't simply say, oh, base plus commission employee, you get employees 1 or employees E. I just can't do this. This is also incorrect, right? I have to downcast it. So you'll say, oh, E is an instance of base plus. Can I just simply assign it back? You can't. You can go from a parent, because remember, parent is at the top, is above in the hierarchy. So you can do this, but you can do this. This can be done, and this is called downcasting. You're saying downcast it to a base plus commission employee object. That's what you're saying. So downcasting, this is called downcasting, right? So you simply cannot assign it. You will have to downcast it and assign it. Okay. So if you want to write it both ways and put a comment for yourself, please do that. So otherwise, assigning a superclass variable, here is the problem. Assigning a superclass variable, or reference, I should call it. They're called reference. I mean, it's a variable to a subclass is not allowed. It's not allowed. It's a compilation error. You just saw it. It was a compilation error. That means I can't do this. I just can't take this and without casting it, I can do it. This will give me an error. It will, right? I can do this. This is not allowed. So assigning a superclass reference, remember E is a superclass reference, though inside it is a BCE, but it is still a superclass reference. You cannot do it. So what will you do? You will have to explicitly cast it. And it's called downcasting. You're going down the hierarchy. So we explicitly downcast it. Now, once you downcast it, now you're okay. Now you can work with BCE2. I didn't use my original BCE because that was a different variable, that was a different employee reference altogether. Now, if you want to give that person a 10% raise, now let's do that. Right? Okay, so you've downcasted it. You have to downcast it because that's what it is. So what did we call it before? What did I call it? Okay, I did call it BCE. So I can now use any other reference name that I require. I just called it 2. And now you increase the base salary. How will you do it? Now you tell me, how will you do it? Now you know, it's just normal Java. Get the salary, multiply by whatever you want to, and put it back. Right? Now you do the normal that you do. So let's start it and do it. You can say increase the base salary by 10%. We'll have to take some figure. Okay, so what do? We take our BCE2. Remember, it's just a reference. You're still referring to the same employee. You're saying, oh, you've put it in a different employee name. It's not the employee names that are different. Oh God, no chalk. Okay, there it is. Okay, so keep in mind what is happening. You created a CE employee. Here is your employee information, okay? You created a BCE employee. There are reference variables. So here is a B information. Then you created a salaried employee. Here is the information. These are reference boxes, not value boxes. And this was your last one. And when I say pointers, I'm meaning addresses. Okay, then you created an employee array. This was your employees array of 4 size, right? What does it have? It is pointing to the same address. Keep in mind, copies are not being made. That's what has happened when you reference it, right? So you created 4 employees. Those 4 employees were created. They are reference variables, not value boxes. So they have an address of where the information is, address and so on. Then you created an array, and this array was again an array of objects. So these are not value boxes. These are again address boxes. So the address here, M1 and M1 will be the same. M2 and M2, because you've kind of copied the address. That's what get copies when you assign. And M3 and M4. Now I say take a new BCE2. Right? I say take a new BCE2 and then downcast this to which it is pointing, M2, downcasting. So basically this is also pointing to this one. All you've done is you've downcasted it. Okay? Like, it's not a big, keep that in mind. These are all references boxes. So now first get the salary and then set it. So there was a set salary, there it is. And then you get it. I'm doing it in one step. Get it. Multiply it by 1.10 and set it back. Here, salary has increased. I just used a different variable because I want to show you that I'm not using BCE. Right? I'm using BCE2. So I downcasted it and then I'm changing the salary. Now keep in mind, whatever the salary of that person was, $300, I think, right? Base plus had a 300. Now it will go up by 10%. So $330 is what you should see in an answer. And we'll have to see, we'll have to double check. This is coming at the end, we'll have to double check. So if you have to do something with the variable, with the reference, you first have to check what are you. So how did I check it? I said if E is an instance of the base plus commission employee, now increase the employee, and just so that to show you that it works, I'm going to do a system.out.println of your BCE here, just to show you that it works. Otherwise, there is no other way of showing it to you that it works. Shift Alt F. There it is. That's how you work with subclass methods, though the reference is a superclass. So this is downcasting because you're coming from a bigger type to a smaller type. Right? It's a parent from the super. If you have to come to a subclass, you will have to do a downcast. Once I do a downcast, see, I don't have a compilation error now. I don't have compilation errors. Now it is fine. Though I had a compilation error when I tried to do this. See, there was a compilation error. I couldn't set it. I was just showing you an example. I couldn't do it. It was a compilation error. But then I said, oh, what do I do then? I said, oh, are you an instance of base plus? Downcast it first. So I downcasted it. Of course, you have to use which one will you use? You won't use commission employee here because you're putting it into a base plus commission employee, right? You want to work with the base plus commission. So you downcast it. And once you downcast it, you can now you can start using its methods. Right, so this should now show me a 330. At the end, it should show me a 330 for the salaried employee. Right, so this is how you check who are you and then call the methods. Otherwise, you can't do it. You can't do it like this. This is incorrect. This is incorrect. Logically, compilation, it won't work. So now let's run it again. So anytime you're working, so let's just look at the last answer. It should give me a. Who was the salaried employee? Just after the second, did I make just after the second one? Are there more? Are you sure? No, it is the last one. I see what you mean. I printed the first one, then the second, then the third, and then the fourth. So at the third one, so you should see 2 of 3s, right? Oh, come on. I can't find my, there you are out. Where are your outputs? Here it is. So after the third one, there it is. So this guy and this guy, 330 and 300. There they are. Notice the difference? First, it is printing with 300 because then I gave the person a 10% raise. It has now got to 300. So it is working. The printing is coming after the third one because I'm printing, changing only the third one. So the all rest are same. This is only a change in the third one. Right? So this is an instance of. So anytime when you use arrays or array list, whatever it is, anytime you use a collection, definitely you would like to use a collection of the parent class. And remember, I'm not using commission one. I'm using employee because everything inherits from employee. When can you use the commission one? You can use the commission employee when you are either working with commission employees or with base plus commission employees. But you have to use employee if you are using any of the four. So it makes sense. Look at this. Oops, look at this. So a base plus commission employee is a commission employee. So reference is available, is also an employee. So it can also be put into an employee object. These two, RD and salaried, can only go into employee objects. You can't put them into commission employee objects by inheritance. Okay. So just so that you understand. So what we've seen is a corollary of inheritance called polymorphism. Many forms, right? Many forms. Many forms of what? Many implementations of the same named method. And depending upon with what kind of reference are you calling it. So when you call it with employees 0, you're actually referring to this person, right? So when you say M1.toString, it says, oh, M1 is a CE employee, so it uses that toString. M1.getEarnings, CE.getEarnings. When you call it with employees 1, it says that's a BCE employee, so it says BCE.toString, BCE getEarnings. Similarly, SE.toString and similarly HE.toString, right? That's polymorphism. That's what is called polymorphism. Many forms. Okay. Just before I leave this example, because we've done so much in this, I would like to show you something else also. Just if you are not sure, I'm just kind of getting I'm hoping I'm in the right one. I think this is my main. That's what happens when you don't put them. You can also just get the type of each instance. This may come handy when you do assignments, or of course when you work further. I'm going to use a for loop again. I could have used a for each. That was not important. That's not important at all, but you know how to do this. This is more bulky. and nobody wants to do it. Oh, semicolon, not. I think you should forget about using these extended for loops. They're just not made for it. Employees is an array. Oh, length is not a method. Oops, length is not a method. It's a variable of it. Okay, so just so that you know. I can print F just because I know it is a. Just showing you the position. That's why I use this. That's why I use this loop. Okay. It's not very neat, but I want to show you what happens. Remember to put it on a different line. And who knows what's coming before it. So I'm going to put a percentage n here. Okay, so the first percentage D gets replaced by I plus 1. That's why I didn't go with the enhanced loop, which I should. Or you can just say I if I makes sense to you, like, because we are showing positions 0, 1, 2, 1, so on. From your employees at the position I. Now here is something that is coming from the object class, just to show you. What am I missing? Get class here. Anything else? Oh, here. Now still something else. Employee at position D. I is a percentage S. Employees I, get your class and get its name. 1 to O. There it is. Now what is this get class method? And how is employees using it? We didn't write any get class method at all. It belongs to the object class. It belongs to the object class. So therefore, I was able to use it with employees I. Every employee is an object, right? And the get name is just getting you a name. I'll show you how it looks, just to show you that, oh, I can use a method of the object class also. So this is how it will look. Do I have any? Do I have? No, the thing. Notice what it is saying. Not very neat, but not bad if you wanted to use it. It's showing you the name of the class from the inherit. That's what it says. It says employee at position 0 is it's telling you from which object of which class. So when you say get class and then you say get its name, it is showing you the name of the class. That's what it does. Just the class name. The get class gets the class and get name gets the name of the class. Right? So you can use a method belonging to the object class also. I saw something red here. What was that? What is it saying here? It's saying something in hourly employee. I see the spelling of hourly employee is wrong, but it is saying something. Just at red. Anything else? Yeah, something is happening at array index bound out of bounds. Oops. Where is this coming from, guys? Where is this coming from? Somewhere for sure. Oh, less than. Okay, thank you. I made a mistake there. Less than length and not equal to length. Perfect. Yep. How can you go till length? Because if I start from 0, it is less than length. Thank you, enough. That's where it is coming from. And there was a spelling error. I saw a spelling error somewhere in my hourly employee. No, that. Oh, there it is, employee. I'm saying, where is the error coming from? We just. Okay, now it's fine. So get class is for your information. You can always double check. Now we are good. The get class is a method of the object class. And you can use it with employees because every employee is also an object. Right? So inheritance has its uses, but again, as I said, it's very tightly coupled. Like you have to be very not careful. I mean, it's inheritance. You just can't forget who's the superclass, who is the super's class, and super. You can't. It just it's in a hierarchy. You have to follow that hierarchy. Okay. Okay. Now also with inheritance comes another sub of it, which is called interfaces. So we've done abstract classes, but you can also inherit from interfaces in Java. There are many interfaces in Java. ArrayList itself, the class that you use, uses many interfaces. If you kind of go and open the ArrayList class in which you've been using for so long in this course, if you go to it, that ArrayList itself, I'll just open the SC, doesn't matter, the 7. You will see how many it's implementing these interfaces. So it is extending the abstract class, but it is implementing. And we haven't talked about implements yet, but implements is directly related to inheritance. So this is the last topic in inheritance that I would like to do. So for this one, I would like you to create a new project, okay? Just so that we don't mess up with this one. So I'll put this on Blackboard for you. I'll kind of put this on Blackboard for you today, okay? So we've kind of completed what we did last week, but we've also done polymorphism, a very powerful programming technique in any object-oriented language, not only in Java, in every, yes. In where? Employ somewhere else? In polymorphism, yes, thank you. Right? So this is a very powerful technique of object-oriented languages. Doesn't matter where, Java or C++, wherever, it's available everywhere. Okay? Few rules to be remembered. Every subclass object is a superclass object. You can use methods of your superclass to whatever level it goes. You can't use the opposite. A superclass object cannot call a method of a subclass object.
Yeah, it's driving me insane.
Who is it?
Yeah, I'm trying to figure out where it is, but it's not for my technology.
It's not irritating me, so I can't hear it. That means maybe somewhere on that around there, because you guys can hear it, right?
It should be mine. Checked.
I think that.
Yeah, it sounds close, but I'm not.
You mean the projector?
No. That's
Sure.
Oh, that white thing?
Whatever this is.
Figure out?
Yeah,
What was it?
grab this charger.
It doesn't usually make that noise, so I don't know why. Maybe it's because of.
Oh, okay, I couldn't hear it, so maybe it's going that way. Okay,
Sorry.
That's
My
okay.
Never done that before.
that's okay. You never know where things are happening, and as I said, I couldn't.
Yeah,
I
this is new for me regarding my charger.
Okay, there you are, right? So we've taken one aspect. Now I want to go a little further. Inheritance, we've done inheritance, but there is a cap on inheritance in Java. You can only extend from one class at a time, right? Of course, that hierarchy can go on because you can create levels, but at any given time, you can only extend from one class. Now, why did they do it to begin with? I would definitely recommend that you go and read a little bit about it, right? So when Java was introduced, it was a rule, and it still is a rule. You cannot extend from more than one class. But to take care of it, maybe doesn't create as much problems on the other side. I don't know. Like I still can't. I mean, I know why they did it, but now they've given us more options. But what you can do is you can implement more than one interfaces. Now, what is an interface is the biggest thing. First, to understand what is an interface and how is it different from a class in Java that you've been doing. And Java 8 and 9 have improved it a lot. It is different from what it used to be. So now stating it now, an interface is a definition in which you can define only constants, nothing else. You can't define instance variable. Only constants can be defined. Abstract methods can be defined by default. If you don't say anything, they're automatically abstract. And now in Java 8 onwards, and 9 has an enhancement too, Java 8 onwards, you can also define default methods. Default methods means methods that have a body implementation, but that's how you will use it everywhere in your classes that inherit from this interface. You can't override them, okay? So an interface is a special kind of class which cannot be instantiated. It's an interface, you cannot instantiate it, in which you can only define constants, public, final, whatever, int, double, whatever, but only constants, and they're all public by default. They're not private. 2, you can also define abstract methods. They're again by default public. And 3, in Java 8, you can also now define default methods, which basically are automatically inherited. So you're kind of seeing multiple inheritance through interfaces that can be that can be done. And Java 9 has also introduced that you can put private variables into it, but all only constants, right? So we'll do the 8 at least, the 9 because we don't have 9 yet on, and I can show it to you, but till 8 I'll work with you. So now let's work with an interface and see how is it different from, what does it add to inheritance in Java, right? So what I've done for that is I've given you two classes on Blackboard. I would like you to pick them up, okay? And I'm going to open a hierarchy for you here. And I'm going to implement this. So I already have the employee and the salaried employee. I'm just keeping it to this. Salaried employee was the easiest one. That's why, right? All other classes were bigger in the sense they had more work, though all we have to do is copy and paste. It really doesn't matter. But salaried, because it's a small class, does nothing, returns you the salary. That's what I'm going to implement it with. But notice how I have a payable interface here. And notice how interface in class diagrams are written with those gillets, they're called. And then I've added another class called invoice that is absolutely not related to employee. You'll say, so what's the sense? That's one of the biggest advantages of interfaces. In interfaces, you can put code that needs to be overwritten and code that can be shared by absolutely unrelated classes. In an inheritance that you just saw, all these classes were related, right? They were all employees, they were all related. But through interface, we can force unrelated classes in the same scenario, of course, right? For example, let's talk about Georgian College. Georgian College employees are paid. So we have different employees in the college, but Georgian College also pays for its services, for its leasing of computers and so on, right? So to both the leasing company and to the employee, the Georgian College, the company Georgian College has to give some money. For me, it is salary. For Dell, from which we lease our computers in our labs, it is just an invoice, right? So here there are two classes that are not related. I am not related to people who give out computers to our college or vice versa, but both of us have something in common. We are both being paid. I am being paid a salary, and that person who is leasing computers to the college is being paid some money for that service. Now, just because both of these classes, though completely unrelated, have something in common, and that something is common for Georgian colleges, how much money do I spend every month or every year? Paying its employees, 1, paying services, 2, paying for any computer leases, which is a service, 3, and so on and so forth. So if Georgian College said, oh, this is my budget and how much do I spend in an year, then it can create an interface called payable, and that interface can have as many methods, but we'll only work with one. And every service or employee or every object that needs to be paid in the college will be inheriting from that. It's called implements, not inheriting. It will implement that payable interface so that the value of earnings or the value of leasing or the value of gardening or the value of fixing rooms, whatever, is all going into somewhere, and everybody has to be paid for it, and we all implement a method called pay, right? I'll call it get earnings. Maybe the person who does leasing calls it get invoice amount or something, or whatever. But we all need to be paid, since we all need to be paid by Georgian College, and the Georgian College says that we should have this somewhere, that every object in Georgian College should have a paying method. This is how it will do it, right? So there are two unrelated classes. Invoice has no relationship with employees, but they are still being put together in the same hierarchy because they are going to override a particular method that basically works for all the objects of the application, right? That's where interfaces are used. So this is a very simple example. So suppose there is a company, and that company has to pay out money to different objects of different kind, and it wants to keep an account of what is being done. It says, oh, every object in my company must have a payable method through which we say this is what is being paid, and then we can put it together and say this is what Georgian College spends. There is where interfaces come in action. So when you use interfaces, you implement them, you don't extend them. And you can implement as many number of interfaces as you like. And the interface in Java as it stands now can have public final variables, constants. It cannot have instance variables, can have abstract, public abstract methods, and can also have default methods whose definition is taken by default. Right? That's what it is. So let's try to write one and then I'll explain what it is. So for this new project, I would like you to pick up those two files that I gave you and create a new project and go from there. I could do it in the same one, but I don't want to mess it up. I mean, they're two different things. Not two different things, two different viewpoints. Okay, so what would you like to call it? Let me first put it in the right place. Intro to Java, summer 2017. You are Tuesday. Okay, so there you are. I'm calling it interface hierarchy. Or you can call it payable. I before E. I'm calling it payable hierarchy. And I'm going to do a finish. And I would like you to copy the two files that I gave you. And also the employee class, the salaried employee class from the one that you've just done, these two classes. So I've given you payable and invoice on Blackboard. Please copy employee and salaried employee from your previous object and put all of these four together, and then we'll change the package statement. Okay, so get all of them at one place. And this is as simple as this. You just go where it is and copy from there. So I'm going to copy from my own, you copy from yours. So employee.java is the first one. Salaried employee is the second one. Payable the third one. Invoice the last one. See? And put it in this new one that you just created. And it was called payable. There it is, payable hierarchy. And put it here. We'll do a refactor. As soon as you do refactor, it also puts the right package statement. Right? So my project is ready. See that you have the same picture as I have. So I gave you two files on Blackboard and I copied my employee and my salaried employee from the project that we just finished. Oh, I hope I copied it from the right one. Okay, I'm going to close everything. And just so that I know. Oh, okay, this is what I gave you to begin with. That's okay. It should be, you should have the same one. Salaried employee, did I make changes? Okay, so this has the set. Okay, so not this one then. Just copy them, okay? Salaried here. Let me delete this one. I'm going to pick it up from your, instead of mine, I'll pick it up from your, the one that we just finished. Delete this. Yep. And so employee and salaried employee. Control C. And refactor them. And you have them. Okay, now we are ready to begin.
Should we create payable hierarchy or it's
No, I created a new project. I did. I didn't want to put it in the same one.
the class?
Oh, that automatically, when you create a project, a class by the same name automatically gets created, payable hierarchy. It does. Automatically. That's the test, kind of, it assumes it is your tester. Right? It automatically does by that name and it will put main inside it. It always does it. It always does it. No, it always does it. So now I'm trying to build this hierarchy. So the first thing you have to understand is what is an interface? 1. 2, what is the use of an interface? Right? And then 3, an example. So what is an interface? An interface is simply it's not a class, can't call it a class, but an interface in Java is a definition. So it's just like this, right? It's just a definition. Instead of the word class, I'm using the word interface that can only contain, it cannot contain any instance variable. Try putting some instance variables. How do you put instance variables? Like you normally do, like something like int x. I can do it. It won't allow me to do it. It says equal to is expected. As soon as it says equals, that means it is a constant. You can only put constants in an interface. So anything that you would like to share amongst all the objects that inherit from this interface, you can put them here. So there is one place where you can put all your constants of your complete project. Every class can do it. You cannot declare, you cannot do it. Oh my God, it's the same thing. I keep forgetting that one of their plugs doesn't work. Okay, am I on now? Yep, I am. Okay, you cannot do this. You cannot have instance variables. I mean, it's a rule. An interface cannot have instance variables. But what it can have, but you can always have constants. By default, they are public. By default, they are public, okay? So even if I just say this, I'm okay. I'm just calling it constant 1, okay? Because I can't think of a name. If you simply say equal to 5, now it says, oh, that's a constant. You don't have to say public or final in front of it. You don't have to. You can only declare constants, but they are by default. By default, they are public and final. I think 5 allows you to put static constants also, if I'm not mistaken. I think Java 9 allows you to put static constants. I have Java 8, so I can test it. So you don't have to put anything in front of it. You could if you like, and I would highly recommend that you make your definitions clear. But if I try to do something like this, see, again, I can do it. I can't. I can only have public final constants in an interface. You cannot even have private ones. It's not allowed in 8. Now 9 I haven't tested, so I shouldn't, oh, my spelling is wrong. But I can do this. It's a normal thing. You've done this before. You've said private final int and you give a value. I can do it. But as soon as I change this to public, I'm okay. Right? So an interface can only have public final constants. Rule number 1. I've shown you everything else doesn't work. Cannot declare instance variables, cannot declare private variables. Till Java 8, I'm only talking Java 8, right? I forget Java 9 because I haven't used it, as I said. Unless you use something, you tend to forget it. You read it and you forget it. But once you use it, you don't forget it. Because you can check, right, if it works or if it doesn't work. So since I have Java 8 installed on my laptop, Java 9 was still in its, it was still in its beta stage when we started summer. So therefore, all of us have Java 8. I'm not sure what's going on right now, but Java 9 was still not ready to be in the market. It was in its beta stage. So I kept to it. So that's what you can do. That's one thing you can definitely do. And as I said, you don't have to say public and final here, but I would highly recommend it because then it makes sense, right? It makes sense to us. 2, an interface can have public abstract methods. And that's the default, even if I don't say it. Even if I don't say it, that's what it is. So try putting something else. So this is its default nature, public abstract. That's its nature, okay, by default. But I don't want you to use defaults. I gave it to you, now we are improving it. So that's what I want to show you. I don't think, and again, this is for 8, you can't have private ones, right? You cannot have private abstract. And it kind of makes sense if you think about it. Like private means cannot belong, it only belongs to the interface. If it only belongs to the interface, it cannot be overridden. Then what's the sense of it? Like logically, there is no sense in it. So I know something has happened in 9, but I'm really not sure what extra has happened. So an interface can only have public abstract methods.
So if I don't write anything, it's assumed automatic.
Exactly, that's its default nature. If you don't like this, if you don't write this here, it's automatic. If you don't write it here, it's automatic, right? Now, what Java 8 has added, so this is what it was till date, till before Java 8. And that's all we had. You'll say, then what's the use? It's such a useless definition. It has nothing. All it has is constants and methods. But its use was this. 1, through implementation, inheritance could be increased. So instead of extending, you can say implements this, comma, this, comma, this, comma, this, and whatever. Unrelated classes can be given a relationship by putting common constants and common methods that need to be overridden in all the classes in the application. Now in Georgian College, Teachers are not related to people who do gardening. You know what I mean? Like, I'm not related to them. I'm related to students, but I'm not related to Dell, who leases computers for our college. There's no relationship between this object, teacher, and the object, service. There is no relationship. There is a relationship between teacher and student because of courses and so on, but otherwise there is no relationship, right? Similarly, there is a relationship between teacher and staff because we are under particular staff member, like certain staff members are related to computer studies department and so on. But if you look at it, services, I'm not related to services at all. It has nothing to do with me. But since Georgian College is an organization and it has to contain all these objects, teacher, faculty, service, non-faculty members, and so on, and it says I have to pay some of these, if I could create an interface in which I put a method called get payment amount. I'm just doing a get payment amount. I'm not calling it get earnings. I'm not calling it get lease payment. I'm just calling it a general name, get payment amount, so that every object that implements this overrides this method. I will override it by saying salary, return my salary, get my earnings. The lease person will give some kind of money, take some kind of money. The people who do extra work in the college will have some other kind of invoice, and so on and so forth. So the use of an interface, is to ensure that all objects, if required, all objects, even though unrelated, in an application can have some kind of rules imposed on it. So if a particular class implements this interface, it has to override that method. There is a rule, it has to. There is nothing else you can do about it. So you're imposing rules. So till now, that's what we had. Then it was felt that what if I want to put some helper methods in there? Methods that every object needs, any object, any class that is implementing it needs. They don't need to override it, it just needs it, and we want it there. And so Java 8 allowed you to put default methods. They're called default, right? It allowed you to put default methods. I'm just giving an example. Very kind of silly example, but oh, I don't want to do any printing here. It can take any object, it really doesn't matter. I'm not doing much in it. But you can create default methods if you want in your class. And default methods are automatically inherited by every class that implements this interface. So these are common methods. I also needed another object. I mean, all different kind of unrelated objects needed, there. So now there are a few advantages. All common constants can go in this class, in this interface. All common methods can go in this interface. They just have to be called default. Default means you cannot override it. It's its default implementation. It cannot be changed. Java 8 added this. So now helper methods could be added inside your class. And Java is full of such examples. Now your abstract list, which actually I was showing you, the abstract list that implements so many of these interfaces, serializable, clonable, iterable, collection, list, random access. What it is doing is in each of these interfaces are some common methods. For example, the collection, the clonable allows you to clone a particular object, right? The iterable allows you to iterate through it. So all these are coming from serializable. You can save objects and pick up objects as objects. Like a whole object can be saved and a whole object can be picked up. These are just interfaces, and Java is full of them, right? Because of its use. So what I'm trying to do here is I'm trying to create this hierarchy in which I'm saying there is an interface that invoice department also inherits and employee also inherits. Implements, not inherit, let me call it implements. And then employee has its own hierarchy on one side, which we've already done. I'm only picking up salary. An invoice could have a hierarchy, but I'm stopping at only one invoice, and this is paying for a particular part. Okay, so what I've given you now, we will open up one by one. So my first aim was to show you what an interface is. I don't think, I'm almost positive, I don't think this can be private. Because again, it makes no sense. Because it has to be shared, right? So you can think of them as static default methods. It cannot be overridden. I'll show you when I write it in something that over implements it. So here are 3 rules. An interface can only have public final constants. It cannot have instance variables. 2, You can, if you want, I mean, it usually will, that's its main purpose, but you can have public abstract methods in an interface. If you want to put concrete methods in an interface, they should have the word default. You can't work without the default. So you'll say, oh, it is a common method. Why is she writing default in front of it? Because I can't do it. I can't. You can't write it without the word default. It says interface abstract methods cannot have any body. So by default, they are abstract. That's their default nature. So if you want to put default methods, then you have to put the default method. So these are concrete methods that can be shared amongst all the objects that implement this interface. They cannot be overridden. You can kind of think them as final methods. Like final constants, these are also final methods. And I think if I do it, it won't complain about it. No, it says something is final in the wrong place. Modifier final not allowed here. Okay, but you cannot override them. I'll show it to you that you cannot. These are just helper methods. No, okay, so the word final cannot be put, but that's their default nature. You cannot override them. I'll show you in one of its subclasses. Okay, that's an interface. That's how an interface is defined. It cannot be instantiated. Its main use is to bring commonality in the various objects in an application that are not even related. And by rule, any class that implements this has to override the abstract method. Has to. It's a rule. You have to. In the abstract class, if you don't do it, you make that class abstract, and it's fine. But here you cannot do it. Okay. Now, once my interface is ready, and this is my main method, the get payment amount. This method has to be implemented in every class that implements this interface. Okay. Now open your invoice Java, which I've given you. It's a very small class. This invoice, as the name suggests, if you kind of know what invoice is what it means is invoice is saying this is the amount you have to pay for this part. So every part has a part number, a part description, and I kept them final, and a quantity and a price per item. So if I have to pay for this, how much do I pay? Quantity multiplied by price per item. Right, so I made a very small invoice class. A very small invoice has been created. And you could have created all of them as final because it's just a small class and I'm not thinking real time at all. But I thought I will show you 2 as finals and 2 without finals so that again I can show you something in validate I did here differently. So these are the instance variables, but please notice this. This class is implementing payable. What does it mean? 1, it means you can use those constants, constant 1 here. Rule number 1. 2, you can use that default method, say hello here. And 3, you must override the get payment amount there. Yes. When you do what? In here, in this one? There it is. You took my class from Blackboard? Okay, what am I missing on Blackboard that I've rectified here? What is it saying? Bring your mouse over it. Get payment amount? Okay, double check with me, please then. What did I do? Do you have a get payment amount here in your payable? That's what it is called, get payment amount, spelling right? And then in your invoice, it's giving you an error here in your get payment amount. Everybody?
The only thing I see here is that missing @ return type. That's why it's highlighted double with yellow.
Is it red? Method does not override payment amount. Bring it again. From a super type. Okay, let's look at the super type. When you copied it, did you put the right? Did you refactor copy? Yes, you did. Okay, so now it says implement payable. Where is your payable? Oh, here it is. The problem is here. You copied it, didn't change the package statement. You didn't change the package statement, you didn't copy it properly. The package statement is wrong. The one that I've given you had a different package statement. I changed it. When you refactor it, it should do it. That's your problem. Here, your problem is right here. Your package statement is wrong in payable. Please give it the same name as the name of your package. There has to be something. I changed it because I did a refactor and it changed it. I think when you copied it, you must have not done a refactor. Something to that effect. I don't know. But that's what the problem is, okay? Your package statement is wrong. When you copy something, it asks you, should I refactor it? And say yes. And then it will automatically change all the statements for you, all the package statements. If you forget to do that, then it is trying to look for payable in that package. And of course, it can't find that package. Okay? Are we okay now? Everybody is okay? No red squigglies now. Okay. So now this is implementing payable. It has 4 variables, instance variables. 2 are final. So the that are final, I've kind of just put them here. Remember final variables? I'll repeat. Final variables cannot have a set method. Why did I make this final? Because part description should be final. It's more than description. It's name. But I mean, more than part description, you should call it part name. Part names don't change, so part numbers don't change. So I made both these finals, right? And then the quantity and the price per item can be changed. So I made them non-final. And keep in mind, anything that's final cannot have a set method. You cannot have a private method, even a private set method. You have to initialize them as normal initializers here. Please again notice the call to super. Right? The call to super says, oh, I'm calling my I'm calling my parent. And if you don't put it, it is automatically put for you. Keep in mind, invoice is still extending object. Even if you don't say extends object, it is still extending object. So that super is kind of useless, but that's what super does. Okay? I mean, that's by default. Now, so final variables need to be initialized right using statements right in your constructor. That job is done. Now, a little differently, what I've done here is this. I have written a validate quantity method, like we write our validate, but what it is returning is a true or a false. This is more work for sure. It returns a true, I say, oh, you're fine. If it returns a false, I throw an exception. Now, this is just to show you that it can be done in another way. And notice what set does. It also uses the same if statement. So this is more code, but I want to show you my validate method. I just saw it in a book and I thought, why not? I'll show it to you. So what does validate do? Validate is not throwing the exception or whatever. All it is throwing is either a true or a false value. It says if it is less than or equal to 0, then I'm going to say less than or equal to 0 is not. Then I'm going to say a false, else I'm going to return it true. So there is no rule which says, oh, you have to write them like this or write them as I was writing in my previous one. But I saw this in another code and I thought, I should just show it to you. So this is just for you. The concept doesn't change. There is a private validate method that is validating your input. I find it more verbose because I have to repeat the if both in my set method also, and I also have to repeat in my constructor also. But as I said, just so that you see things. And it's always good to see somebody else's viewpoint also. So instead of just calling validate, I kind of made it return a Boolean value and then used it. Just something I saw. Okay. Now let's look at the last one. Get quantity simple. Set quantity is again using validate. Get price item simple. Set price item is again validating it. Get part number, get part description normal. There are no set methods because these are final variables. And these are my validate methods. And here is my method. Now, if by any chance I remove it, I do a control X. It is going to give me an error right at the top. Why? Because it says if you're implementing it, you need to override it. I have to. That is a rule. And notice, because it is a rule, this kind of forces every class that implements this interface, it forces every class to run it. Now let's try the opposite. The default method that you had written. I'm going to override that method. I can't, but I will show you. I can do it. So let's go to the invoice, and just for the heck of it, copy it here, put an override in front of it, remove the word default though, and bring your mouse over. It says default not allowed here, so I'm going to remove it. Oh, it does allow you to override it. Oh, sorry, my mistake then. Oops. Oh, so default says if you don't override it, you can use it. Right. Okay, I'm so sorry. Default means if you don't override it, you can use it. And if you want to override it, you could. but you have a default implementation, so that if old code is implementing this, it does not break, because therefore you've called it default. Okay, so default methods can be overwritten. I'm so sorry, it makes sense now that I see it. Default means this is its default definition. If you use it, good. If you want to override it, do it. But the use of default in Java 8 was this. Old interface, old classes didn't have to be remodified because it was a default methods were added to interfaces. New classes that implemented it got it and could override it. Old classes that were implementing it didn't break because these methods were default. That's why they were called default. Okay, so you can override default methods, but you don't have to put the word default. But the default word was put for those classes that were already implementing from it. So their code did not break. That's why it was called default. Okay, and then here I've shown you something new again. Here I found this again while I was reading code from somewhere. Since the toString method is overriding the toString of the objects, you can also write something like this in your code. It says see java.lang.object.toString if you want to look at its definition. I think programmers who kind of write professionally kind of put this statement, right? So notice how I've written here. It says at C. So at C is an annotation. Look at Java lang object toString method if you want to know what are its original, what does it do, and so on. Then you don't even have to do this. You can remove this from here if you like. It says refer to that method. That's what it says. Okay, so you can do that, and it's done by, I've seen it being done, so I gave it to you. And what does the toString method do? Normal toString invoice. It is showing you the invoice, showing you the part number, the description, the quantity, and the price per item. That's all it is doing. So it's a normal class. Invoice is a normal class. I just added 2 final and 2 non-final variables to it just to make it a little, so that I could repeat what are finals and what are non-finals. Implement says that now you have to implement every abstract method in the class that you are implementing. The default one was added in Java 8 to keep old classes intact. They didn't have to be disturbed, but new classes, if they wanted, they could either override it or use the default. The use of default methods, for your information, they're helper methods. Anything that you would like to kind of add for all classes, they're just there by default, right? That's an interface. So I've showed you how to do an interface and how to implement it. Now, so I'm trying to create this hierarchy, and the only common thing between an invoice and an employee is that they are both paid. They both are paid. So therefore you have that method, get payment. How much do I pay? So how much do you pay an invoice? By that formula, number of parts, number multiplied by number of whatever, right? Now, remember in my employee hierarchy, that method was called get earnings, right? That is what it was called, get earnings. But the employee was an abstract class. So what do I do there is what I want to show you. Yes?
What do you not make it default in the table method?
You can't write the word default with it. You cannot. It's not allowed. Syntactically, it is not allowed. Default methods are only allowed in interfaces, nowhere else. You can't put it in a class definition.
But then it would be like because it's not default, it can override.
No, default says anything that implements table can use that method if they want, or can override it if they want. You can override it, but you just remove the word default from it. Okay. That's all it means. So default was put in interfaces. I'm telling you why it was put. So that classes that were already implementing, old classes that were already implementing that interface did not break. There was no compilation. So use the default nature. And then new classes would override it if you want. So you can override them. Or what is default? Use it by default if you don't override it. And it has its use, right? I mean, it's just a definition that may or may not change. But you don't have to override it. That's not compulsory. Now you tell me what has to be done. There are 5 minutes. We can't complete it. But you tell me what should I be doing in my employee class now? Employee class, which is extending object, add, implements table to it. To create this hierarchy on the right hand side. To create this hierarchy, I have to say, and notice the difference between this and the other diagram that we have been using till now. Here you see that the arrows are solid. Right? In an interface, you will see that the arrows are, the lines are broken. So again, these are just class diagrams for you. And this is a class, this is an interface, and a class doesn't have that interface written. But of course, this class diagrams are small. Don't forget you have class diagrams in which you show all your instance variables and all your methods. We've done that in the beginning. This was too much. I didn't want to do it, and it was in the book, and I didn't want to do extra work. Okay, so now you tell me, how do I say, so here, I want now employee to implement payable, which means it has to override which method? It has to, oh, why is it not complaining? Why is it not complaining? Oh, because I have this here. That's why it's not complaining. There it is. Oh, yep, now it is complaining. What do I need to do now? I have to implement the get payment amount method. But the problem is that the get payment amount method is not common for all the employees. We just saw it was different in all my 4 type of employees. So what do? I have to kind of work around it. So this is my workaround and see if it makes sense to you. Okay, see if it makes sense. So you have to work around. So I'm going to copy that method, just its signature so that I don't mess it up. I come back to my employee. I add it wherever you like and bring your mouse over it. It will tell you what the problem is. Employee is not abstract and does not override abstract method of get earnings. Okay, so I have to do 2 things. So one I'll do first then. I'm going to add this method that I just took from there, and I have to override it. And how do I override it? Look at what I will do. I'm going to return the value of get earnings here. Because I cannot write a formula here because it's different for all my various employees. I do this. I implement it, but notice what I do in the implementation. I return the value of get earnings, which is an abstract. Now salaried employee or any other employee that extends this class already has this method get payment amount and will override the get earnings. So now when I want to look at that person's weekly salary, instead of calling get earnings, I will just call get payment amount, and my job is done. Right? Okay, so now let's again look. Because it was implementing it, I kind of have to, it's a rule. I have to do this. I did it, right? Now let's bring our mouse over it. I'm getting a warning. Oh, it says add override. Okay, so let's do that. Always look at warnings also. Okay, job 1 done. It still has something. No, it's gone. Okay, now let's go back. So look at this, what I did. I didn't want to get payment amount was different, belongs to the employee class, but I don't know which employee am I talking about. So I did this where I said, okay, you return the earnings. And get earnings is an abstract method. If it is an abstract method, I still have to say abstract in front of it. And my error should go away. Oh, what doesn't it like now? Spelling mistake, thank you. I thought, what doesn't logically it like right now? Okay, there it is. So what did I do in my employee class? I added a method get payable amount because I wanted to implement the payable interface. And you say, why are you implementing it? Because every employee needs that method, right? Every employee. And I kind of smartly said, you return the value of get earnings. Okay, one job there. Now come to your salaried one. So this should not show you any errors. Come to your salaried one. Do I need any change in this? No, everything looks fine. But now comes the question, how do I see this person's salary? Kind of, how do I see the salary? I won't use get earnings. I will use get payment amount. That's how I'll force it. Okay, that's how I'll force it. So, okay, we'll stop here, but I'll very quick, that's the main problem. Next time I come, I'll have to spend 10 minutes to kind of revise it. But I'll take 10-15 minutes from the next class to finish this off. That's all that is left in inheritance. And then I will try to do a final exam review with you next week. Try to show you something that you've seen so that when you see it in the final exam, it's not a shock. Right? Something, I'm hoping I can do that. So that was the aim, to leave the last class free for me, the last week. So I will definitely do something new. You will definitely learn something new, but you will also kind of get an idea of what may come in the final exam. So it will act as a review plus a class. So I'll take 15 minutes maybe next week, and then we'll do the new thing. I want to do hash maps and tree maps. We've done array list. We've done quite a bit of parallels, but I want to do something new so that when exam I ask you to look up the library, you know what these things mean. Okay? So we'll stop here. I'll come back to this. It's not a big deal. Therefore, I was only doing salad. I thought I would be able to finish it, but I have still to write the tester and everything, and that will take 15-20 minutes. So I'll come back, okay? I'll come back and do this. What I can do for you definitely is put this on Blackboard.